So in the last section in 2.4, we were looking at a library of functions. Right? We had like the squaring function, the cubing function, square root function, cube root function, absolute value function, a reciprocal function, and we had lines like horizontal line and then an ordinary line. So you got to know how to graph all those functions. Those are kind of your basic parent. I'm going to call those parent functions. So the parent functions are from our library of functions. And then we learn how to do piecewise functions. Right? We took those parent functions and we broke off little pieces and kind of put them together. So in this section, we're going to look at transforming functions. So how do you take some of those parent functions and how do you transform them? So I've created a little table here, which you'll find useful for the different types of transformations we're going to have. So the idea is, first of all, you start off with a function called a parent function. I call it a parent function, y equals f of x. That's going to be our parent function. Y equals f of x is our parent function. And it's going to have a graph. And then we're going to take two numbers, let's call them h and k. They're going to be positive numbers. And then we'll take two other numbers, we'll call them a and c. They'll also be positive numbers. And from the parent function and these red and blue numbers, we're going to do some transforming that green parent function. So we want to focus on the first transformation here in our table. So I call this a new function here. So can I circle? Yeah, I can circle this. Y equals f of x plus k. So this is taking the original function, y equals f of x, and putting a plus k outside of the function. I'll say outside of the house. That'll be the terminology I use. Outside of the house, I like to use that terminology. So let's focus on that for a moment, that new function. So here's a vertical axis. We'll think about that as the y-axis, and here's a horizontal axis. We'll think about this as the x-axis. And let's start off with the parent function here. Okay, so I'm going to take this point right here, and this is going to be my key point I focus on right here. Now this function is y equals f of x. This is the parent, the original function. And that green point right there, well, it's supposed to be green. The input is x, and the y value, the output, is f of x. So I'm going to take the x coordinate down to the x-axis. I'll call that the input x, and the y value I'll take to the y-axis, and I'll call that f of x. Right, the y value is f of x. Now let's take a new function here, y equals f of x, and then we're going to have a plus k outside of the house. So this is the one we wanted to focus on, this plus k outside of the house, this new function. So the input here is still x, but the y value now is f of x plus k. That's the output. So imagine where f of x plus k would be on the y-axis. So you're going to take f of x and add k. So let's say k is the distance between f of x and this new little segment I'm putting there. So we'll call this output here f of x plus k. So I've basically taken a chunk of k and added it to f of x. So here the input was x, and the output was f of x plus k. So here's our new point. So I'll write it like this. So the input was x, the output, the y value, was f of x plus k. So basically what happened was that green point that I was focusing on got shifted up k units. So let's go back to this starting place here, the origin. That's going to move up k units. And let's say this ending green point, that's going to move up k units as well. So everything just shifts up k units. So basically what we've done, we've added k to all the y coordinates. I mean, if you focus on the original y coordinate, f of x, basically k got added to that. So you have to add k to every single y coordinate. So everything shifts up k units. Now that's what I've actually written here in my description. So coordinate-wise, k is added to all the original y coordinates. And graphically, the parent function, y equals f of x, got shifted up k units. Okay, so our next new function is y equals f of x minus k. So that's a minus k outside of the house, a minus k outside of the house. That's just going to shift down k units. So you're going to subtract k from all the original y coordinates, and you're going to shift everything down k. So it's pretty similar to the previous one. When you had a plus k outside of the house, you move up k units. When you have a minus k outside of the house, you move down k units. So I'm not going to go through that because it's quite similar to the one we've just done. So what I want to do, I want to go to this next one here. Y equals f of x minus h. Now this is a different type entirely. So notice it has a minus h inside of the house. Minus h inside of the house. So it's not outside of the house like the previous two, it's inside of the house. So this one acts rather strange, and you can read it in the table what happens. But I want to do this, I want to show how this actually works. It's a bit more complex than the shifting up k and the shifting down k to explain. It's a little more difficult to explain, so I want to go through the explanations. So you have some clue why this is the case, why this will be the case, how this works. Okay, so what we're going to do, we're going to start off by doing an x-axis and a y-axis. A vertical here, horizontal here. And we'll start off with, this will be our parent function, let's say. I'll focus on this point. So this is parent. This is the mama function, y equals f of x. Uh-oh. So my input is x, my output y is f of x. So I trace the input back to the x-axis, that's the x-coordinate. I trace the output f of x back to the y-axis, so my output here is f of x. Now what I want to do, I want to focus on this new function called y equal f of x minus h. Now the minus h, the h is just a fixed number. It's just some number. That could be like 2 or 3 or something. But the x varies. The x can be anything it wants to be. So let's take my function, my red function, and the minus h is going to stay. Now the x can be anything it wants. So what I'm going to do, I'm going to plug in place of the x right here, in place of that x, I'm going to put x minus h as an input. So I'm replacing the x with an x plus h. X plus h. Okay? So what actually happens now? What does the output become? What does the y value become? Well, what happens is the h and the minus h cancel, and I get the output as f of x. So in reality, into this new red function, I've put in x plus h. Right? This is the input right here in black. X plus h is the input. And the y value, the output is now f of x. So let's put this down on our graph. So where would x plus h be on the x-axis? Well, you're going to add h to the x-coordinate. So here you're going to have x plus h. Okay? And the y value, the y output is now f of x. So right here. So you're going to have x plus h as your input, and as your output, you have f of x. Okay? So what happened? Well, that green point that we were focusing on back here, that got shifted to the right h units. We basically added h to the x-coordinate. So all those points, let's say this point back here at the origin, that's going to get shifted to the right h units. And this green point up here, that's going to get shifted right h units as well. So everything gets shifted right h units. And if you continue doing that, you get something that looks like that. So that would be your y equals f of x minus h function. So notice that inside of the house, you have a minus h, and rather than moving to the left h like you might expect it, it moves to the right h. So inside of the house, things kind of behave opposite of what you expect. So inside of the house, it's going to behave in a horizontal motion from like left and right. It's going to be a left and right, but it's going to be the opposite of the sign. Opposite of the sign. So you had a minus h, so you actually move right h. Now, let's actually see that in our table, right? So we had a f of x minus h, so we're actually adding I can get this to work. We're actually adding, rather than subtracting h, we're actually adding h to the x coordinates, and we're actually shifting right h units. So yeah. So when you have like a plus k or a minus k outside of the house, you're going to go up and down in the direction of the sign. But if you're inside of the house, if you have a minus h, you're going to go either right or left. If it's a minus, you go right. If it's a plus, you're going to go left. So it behaves in the opposite direction of the sign horizontally. Yeah, so I'm not going to do the plus h. It's just like the minus h, except, yeah. So you want to know so first you have your vertical shifts. Vertical shifts are plus k goes up k, minus k goes down k. Then you have your horizontal shifts. Minus h goes right h, plus h goes left h. Okay, so the next thing we want to do here, I'll do these blue. I'll call these blue. We'll take this y equals minus f of x. We'll focus on that one. Y equals minus f of x. See what happens here. Okay. Oh, I gotta erase some more. Okay, get some. There we go. Erase all those stray marks. Okay, so let's say I start off with a parent function. And let's say it does something like this. This is y equals f of x. So I'm going to focus on this key point here in the middle. I'm going to call the input x, and the output y is going to be f of x. I trace this back to the x-axis, I get x as the input, and trace this back to the y-axis, I get f of x as an output. Okay, now I want to focus on this new function. We're going to call this y equals minus f of x. If you think about the input is still x, but the output now, the y value is minus f of x. So where's minus f of x? It's a negative y value. It's on the other side of the x-axis. It's over here at minus f of x. If I trace this x and minus f of x together, I get this key point here of x comma minus f of x. So what happened to that green point here that we were focusing on? It got reflected about the x-axis. It flipped upside down. So same thing's going to happen over here. The green point is going to get reflected, but actually it'll stay right there since it's right on the x-axis. And this green point here up top is going to get reflected as well about the x-axis. It'll go down somewhere here. So we'll have, if we connect the dots, we get something like this. So it's kind of a mirror image. So y equals minus f of x is a mirror image about the x-axis. So really what happened is we took this, this f of x, the f of x from the parent function, and we multiplied it by -1. We took the y coordinate, we multiplied it by -1 to get the y coordinate for the new function. Yeah. And that's how we describe that in our table, right? So original y coordinates got multiplied by -1, and that basically reflects the parent graph y equals f of x about the x-axis. So it flips it upside down. Now, if we were to take y equals f of negative x, y equals f of negative x, that's where you have a minus not out in front of the house, not out in front of the function, but inside of the function. that's going to basically multiply all the x coordinates by -1, and it's going to reflect everything about the y-axis. So things are going to flip about the y-axis. I'm not going to go through that. It's kind of a similar explanation as to the previous one, so you want to know that. The next thing we want to focus on is what happens when you put a positive number, a, so a is a positive number right here. So maybe I should emphasize that a here is positive. What happens when you take a positive number and multiply it out in front of a function? Well, in the table, I describe what happens, but let's actually demonstrate what happens graphically. So we'll draw this out like we've been doing. I don't like vacuum cleaners, they're very noisy. Not a fan of vacuum cleaners. All right, so let's say we have a parent function. How am I going to do this? Let's call this y equals f of x. And focus on this point here in the middle. Typical point would be x as an input, f of x as an output, right? That's the y value. Trace this back to the x-axis, the x-coordinate, you get x. Trace the y-coordinate back to the y-axis, you get f of x. So what we want to do here, we want to do a little demonstration where we have f of 2x. F of 2x. Well, let's look at that. Y equals f of 2x. So I'm going to focus on that for a moment. So notice that the 2 is a constant that doesn't change, but the x, no, I don't want to do that. This thing is so loud. I wish they didn't do those vacuum cleaners during the middle of the day here at the university. It's a little annoying. People have classes and stuff. 2 times f of x. This is the one we want. 2 times f of x. So here we have a number 2 out in front of our f of x. 2 times f of x. This is the function we want. So here we have a number multiplied out in front of the house. Now, what we could do, we could plug in anything for x if we wanted to. Nah, we're not going to focus on that. Okay, let's just see what happens. So the input's still x, right? You still plug in x, but the output is now twice f of x, right? Our y value is now twice f of x. So if you doubled f of x, that would be like right here, right? This would be double f of x. So my input is x, my output is double f of x, 2 times f of x. So this would be my blue point right here. So I'll write it this way. The input is x, the output is 2 times f of x. Now if you think about this point right here at the beginning, that's 0, 0. So basically my 0 would stay the same, and I would double 0 and I would still get 0, so my blue point would go here for that. And if I take this last point here, the x stays the same, but I'm going to double my height. I'm going to double my height there, so that's double. So if you imagine doubling that height, that would go somewhere like maybe up here. 1, 2, 3, 4, 5. 1, 2, 3, 4. Oh, up here a little higher. So everything gets doubled, and you get something like that. So the x values stay the same, but the y values get doubled. So basically we multiplied the y values by a positive 2. Now, this is a vertical stretch. A vertical stretch. So when when your number out in front, in this case, what was out in front of our f of x? It was a 2, right? It's a 2, so here we're going to have, because that's bigger than 1, since 2 is bigger than 1, we get a vertical stretch. Now also, we could do something like look at, let's look at y equals 1/2 times f of x. So this time we have a 1/2 out in front of the function. So if I go back to my green point right here, that central point in the middle, the input is still x, but this time the output, the y value, is 1/2 f of x. So basically we take f of x and cut it in half. That would be right here. 1/2 f of x would be here on the y-axis. And if we put these together, our red point would be right here. So what have we done? We basically, let's write it down, we put in x for an input and 1/2 f of x for an output. So we've only 1/2'd the y value. We haven't done anything to the x value, but we've 1/2 the y value. So if you take that green point back at the beginning, this one right here, and you multiply the y value by 1/2, you still get 0 for a y value, so that's going to put a point here. And if you take this end green point here, and you 1/2 the y value, 1, 2, 3, 4, 5, that would put your red point somewhere like about here. And if you connect these, you get a red graph like that. So this would be y equals 1/2 times f of x. So notice that your number out in front of f of x, this 1/2 right here, is 1/2. So since 1/2 is between 0 and 1, you get a vertical compression. A compression is when you take the green graph and you kind of press it down. You press it down. You don't stretch it out, you press it down. So these are called the vertical stretches and compressions, and we have that here in our graph. Let's look at our graph here. So you have a number times f of x out in front of the house where your number is positive. Basically, you take your original y coordinates and multiply them all by a. And if a is bigger than 1, then you stretch things out vertically. If a is between 0 and 1, like a fraction, like a half or a third or a fourth, you're going to compress things vertically. Okay, we got one more transformation we need to look at. And that's when you take y equals f of some number times x. And this number c is going to be positive as well. We want to emphasize it's positive. So that's when you multiply inside of the house by a number. So before we multiplied outside of the house, out in front of the function, this time we're going to multiply inside of the function by a number. So here we go to explain how things work. Okay, erasing everything from before. Okay, so here I am. I got my, how do I want to do this? X-axis, and that's my y-axis, and this is my x-axis. And we're going to start off with a parent function. Get rid of that. Parent function. It's just some generic parent function, y equals f of x. And we'll focus on this key point here in the middle. Typical, this is like a typical point. The input is x, and the y value output is f of x. So I'll write down that ordered pair, x comma f of x. Now what I want to do this time, I want to focus on something called f of 2x. Y equals f of 2x. So you have to be really careful with this type. So here the input is x, Here the input is x and the output is f of 2x. So what we can do, we can plug in something else for x. You're allowed to plug in anything for x. So right here, I'm going to change what I plug in. Rather than plugging in x here, I'm going to plug in 1/2 x. 1/2 x. So let's see what happens. So I'm going to do some scratch work on the side. I'm going to have y equals f of 2 times. So rather than plugging in x, I'm going to plug in 1/2 x. And I don't know if you know your arithmetic very well, but what happens is this 2 on top cancels with 2 on bottom, and you just get 1x or simply x. So when you plug in 1/2 into this blue function, when you plug in 1/2 x, your output is f of x. Oh, crap. Right here. So our input was 1/2 x, our output is f of x. So we'll write that down. 1/2 x is the input, the output is f of x. So notice what we did for this new blue function, f of 2x, we basically multiplied our x value by 1/2. So even though you see a 2 out front, I'll make this 2 red right here. Try to make it red. See this 2 right here? That's red. Even though that's a 2, in reality, it multiplies the x-coordinate by 1/2. It halves the x-coordinate. Now, if I go back to this origin point, 0, 0, on my original function, my parent function, and I multiply the x-coordinate by 1/2, it's just going to stay 0. So a red point goes there. And let's say I go to this point here on the right of my original function, and let's say I multiply my x-coordinate by 1/2, it's going to half my x-coordinate. So the x value is going to be somewhere here. Oh, these should be blue, right? These should be blue, not red. So the y values don't change. The f of x doesn't change. It's going to be actually multiplying the x-coordinates by 1/2. So you're going to get something like this for your blue function, f of 2x, y equals f of 2x. So here, notice we had a c value, that's this number, the 2 right here. So since c is greater than 1, this is going to compress horizontally. Remember when we said when you're inside of the house, things work backwards of what you expect? You would think, oh, I have a number bigger than 1, so it would stretch things out horizontally. No, it does the opposite. So inside of the house, things behave oppositely. You're going to compress things horizontally. Now let's say we take another function. Let's say we take this function f, come on, let's write y equals f of 1/2 times x. 1/2 times x. So I'm going to think about, okay, what could I plug in for x here? In place of the x, I'm going to plug in 2x. I'm going to take y equals f of 1/2. So 1/2 is a constant, but in place of x, in place of that variable x, I'm going to plug in 2 times x. And what happens here is the 2 on bottom here cancels with the 2 on top, and we get an output, a y value of f of x for this function. So our input, remember here, was 2x. That was our input. So let's double x here. So x was right here. Let's double x. Double x would be right there. That's double x. And f of x is now the output when we doubled x. So right here would be our point. So we plugged in 2x into the function, and the output became f of x. So you can do everything for all the other green points. You can double the x values. That'll put a point here, and that'll put a point here. So you'll get this kind of thing when you double all the x values. Okay, so when you have a 1/2 inside of the house in front of the x, it doubles the x value, so it behaves oppositely. So you actually got a horizontal stretch. So since, we're going to say here, since the C value, that's 1/2, since the C value, which is 1/2, is between 0 and 1, then it stretches vertically. Okay, so that's an explanation for how all these work. So we said when you have a C multiplied inside of the house, you multiply by the reciprocal. Multiply by the reciprocal, 1/C. It stretches horizontally if C is between 0 and 1. It compresses horizontally if C is bigger than 1. Okay, so you want to know this table. You want to know this table. You want to know 1, 2, 3, 4, 5, 6, 7, 8 different transformations.